Hello students, so in this lecture we will discuss about microscopic techniques, and there will be a series of lectures. So this is the first lecture of the microscopic lecture series. So uh, in microscopy there are three methods only which can image atoms individually and study their behavior directly. Those three techniques are, the first one is called the transmission electron microscopy, TEM. Second technique is scanning tunneling microscopy, and the third one is called FIM, field line microscopy. Now, conduction electrons in metal and one-dimensional potential box. So consider that since in electron microscopy, especially when we are talking about TEM or STM, where there is a tunneling of electron, so we are dealing with electrons, which are conduction electrons. Now, these conduction electrons in metal especially they are one dimensional. They are considered to be in one dimensional potential box. And the probability of the electron at the Fermi level to tunnel through the barrier at Fermi level F to tunnel through a barrier is equal to e to the power minus alpha a. That means if you have a potential barrier like this, one dimensional, and you have an electron e to the power ikx, consider it to be a wave, so it can actually, even if its energy E is less than potential energy V, it can still tunnel through the barrier in spite of having energy E less than V, and the probability of this tunnel is given as e to the power minus alpha a, where a is the distance separating two pieces of metals, and you can call a, this is the barrier distance a, and distance we'll call it separating two metals. That means in case of tunneling microscope, say if this is the tip and this is the sample, this represents as a, the distance between the sample and the tip, and alpha is a constant which depends upon the barrier height. So whenever we scan the tip through the sample, what it does is it measures the changes in current. Changes in current are being measured, and the probe, this probe, this is actually attached to a piezoelectric, call it as PZE, piezoelectric ceramic, which provides the necessary change in the topography of the surface, and we get the surface structure. And this is actually used in case of STM. And TM, only technique which determines the budget vectors. TM, on the other hand, is the only technique which can find out the budget vector. The budget vector is the dislocation vector. So we have a dislocation. Right? It moves, it glides through the lattice in terms of this budget vector. And also in TM, and for that instance in HRTM, high resolution transmission electron microscope, a resolution atomic scale of about 2 angstrom can be achieved. So it's a very high precision microscope. In SEM, however, we scanning electron microscope, we also have a tungsten or a lab 6 filament. That means they are the source of electrons. And electron generation takes place either through a thermionic emission, when you heat the tungsten filament and it produces electron, or it can be through field emission as well. And it scans the sample. The sample should be conducting. The sample should have a conducting surface. In that case, if the sample is not conducting, for example, a ceramic or a polymer, we actually provide a coating of gold on the sample to make it conducting. Now, there is an attachment in SEM, usually also found in the case of TM as well, that is called EDS. EDS stands for energy disruptive energy derived, not disruptive, spectroscopy. So what is basically X-rays. So whenever an electron is interacting with a specimen, the interaction of a prime electron with the specimen, it leads to the following phenomena. First of all, there is other electron emission. Then there is emission of X-rays. Then there is visible UV IR radiations, and we we actually introduce conductivity or induction of conductivity. On the sample by creation of free electrons and holes. So these are the phenomena taking place. And while this X-ray that has been emitted, it is used for characterize the elemental composition. Gives the elemental composition of the sample.